Hello friends, and welcome to the tutorial on matrices. At the end of this tutorial, you will be able to create matrices using data, create matrices from lists, do basic metric operations like addition, multiplication, then perform operations to find out the inverse of matrix, determinant of a matrix, eigenvalues and eigenvectors of a matrix, norm of a matrix, singular value decomposition of a matrix. So, before beginning this tutorial, we would suggest you to complete the tutorial on getting started with lists, then getting started with arrays and accessing parts of arrays. Let us start our IPython interpreter by pylab loaded. So type IPython space -pylab in terminal. All matrix operations are done using arrays. Thus, all the operations on arrays are valid on matrices only. A matrix may be created as, you can type on the terminal, M1 is equal to arrays within brackets and in square brackets 1, 2, 3, 4 and hit enter. Using the method shape, we can find out the shape or size of the matrix. So type M1 dot shape and hit enter. So you can see the output there. Since it is a one row 4 column matrix, it returned tuple. It returned a tuple 1 by 4. So a list can also be converted to a matrix as follows. So type L1 equal to, within square brackets, 1, 2, 3, 4, that's in one bracket, and comma in another square bracket 5, 6, 7, 8. Then type M2 is equal to array within brackets 11. You have to type L1, array L1. Pause the video here and try out the following exercise and resume the video. Create a two-dimensional matrix M3 of order 2 by 4 with elements 5, 6, 7, 8, 9, 10, 11, 12. For that, now switch to terminal for solution. So M3 can be created as, type M3 is equal to array within closing brackets, inside square brackets now 5, 6, 7, 8, comma in another square brackets 9, 10, 11, 12. Let us now move to matrix operations. We can do matrix addition and subtraction easily. So M3 plus M2 does element by element addition, that is matrix addition. Note that both the matrices should be of the same order. So type M3 plus M2 and hit enter. So you can see the output. Similarly, M3 minus M2 does matrix subtraction, that is element by element subtraction. So you can try out by typing M3 minus M2. Now let us try matrix multiplication. So type M3 star M2. Note that in arrays M3 star M2 does element wise multiplication and not matrix multiplication. Matrix multiplication is matrix multiplication in matrices are done using the function dot. So type dot within brackets M3, M2 and hit enter. So we can see an error value shown in the command. Due to size mismatch, the multiplication could not be done and it returned an error. Now let us see an example for matrix multiplication. For doing matrix multiplication, we need to have two matrices of the order n by m and m by r, and the resulting matrix will be of the order n by r. Thus, let us first create two matrices which are compatible for multiplication. So type m1 dot shape and hit enter. Matrix m1 is of the shape 1 by 4. Let us create another one of the order 4 by 2. So type m4 is equal to arrays in closing brackets, inside square brackets, then each two values are given in separate square brackets. So 1 comma 2 comma then 3 comma 4 comma 5 comma 6 comma 7 comma 8. Then type dot within brackets m1 comma m4. Thus the dot function is used for matrix multiplication. So as we already learned in arrays, the function identity which creates an identity matrix of the order n by n, the function zeros which creates a matrix of the order m by n with all zeros, the function zeros like function which creates a matrix with zeros with the shape of the matrix passed, then the function ones which creates a matrix of order m by n with all ones, the function ones underscore like which creates a matrix with ones with the shape of matrix passed. All these functions can also be used with matrices. So now let us see how to find out the transpose of a matrix. We can do by typing print m4 in the command, then type m4 dot t where the t is capital. As you saw, matrix name dot capital T will give the transpose of a matrix. So now pause the video here and try out the following exercise and resume the video. Find out the Frobenius norm of inverse of a 4 by 4 matrix. The matrix being m5 is equal to arrange within brackets 1 comma 17 dot reshape to 4 comma 4. The Frobenius norm of a matrix is defined as the square root of the sum of the absolute squares of its elements. So now switch to terminal for the solution. Let us create the matrix m5 by using the data provided in the question. So type m5 is equal to arrange within brackets 1 comma 17 dot reshape, then within brackets 4 comma 4, then type print m5. The inverse of a matrix A raised to minus 1 is also called the reciprocal matrix, such that A multiplied by A inverse will give 1. The Frobenius norms of a matrix is defined as square root of sum of squares of elements in the matrix. The inverse of a matrix can be found using the function inv within brackets A. So you can type on the terminal im5 is equal to inv within brackets m5. Then and the Frobenius norm of the matrix im5 can be found out as sum is equal to 0 for each in im5 dot flatten function within closing brackets So now then type sum plus is equal to each star each, that is each multiplied by each. Then type print sqrt within brackets sum. Thus we have successfully obtained the Frobenius norm of the matrix M5. So now pause the video here and try out the following exercise and resume the video. Find out the infinity norm of the matrix IM5. The infinity norm of a matrix is defined as the maximum value of sum of the absolute of elements in each row. So now switch to terminal for solution. So type sum underscore rows is equal to square brackets, then type for I in IM5 colon, then type sum underscore rows dot append within brackets abs within brackets I dot sum closing brackets. Then type print max within brackets sum underscore rows. Well, to find out the Frobenius norm and infinity norm, we have an even easier method. So let us see that now. The norm of a matrix can be found out using the method norm. So using norm function we can see that. In order to find out the Frobenius norm of the matrix IM5, we do norm. So in the terminal you can type norm within brackets IM5 and hit enter. And to find out the infinity norm of the matrix IM5, we do norm within brackets IM5 comma ORD is equal to INF. This is easier when compared to the code we wrote. Read the documentation of norm to read up more about ORD and the possible types of norms the norm function produces. Now let us find out the determinant of the matrix M5. The determinant of a square matrix can be obtained by using the function det closing brackets, and the determinant of M5 can be found out as, so type det within brackets M5. Hence we get the determinant. Let us now move on to eigenvectors and eigenvalues. The eigenvalues and eigenvector of a square matrix can be computed using the function eig, that is eig, and eigenvalue, that is eigvals. So let us find out the eigenvalues and eigenvectors of a matrix M5. We find them as typing eig within brackets M5 in the terminal. Note that it returned a tuple of two matrices. The first element in the tuple are the eigenvalues and the second element in the tuple are the eigenvectors. Thus the eigenvalues are given by eig within brackets M5 and in square brackets 0, then and the eigenvectors are given by eig within brackets M5 within square brackets 1. The eigenvalues can also be computed using the function eigvals as typing on the terminal eigvals and within brackets M5. Now let us learn how to do the singular value decomposition of or SVD of a matrix. Suppose M is an M cross in matrix whose entries come from the field K, which is either the field of real numbers or the field of complex numbers. Then there exists the factorization of a form M is equal to U sigma V star, where U is an M by M unitary matrix over K. The matrix sigma is an M by N, that is diagonal matrix, and with non-negative real numbers on the diagonal, and V is an N by N unitary matrix over K, that is V star, which denotes the conjugate transpose of V in that node. Such a factorization is called the singular value decomposition of M. the SVD of matrix M5 can be found as, so now open the terminal and type SVD within brackets M5. Notice that it returns a tuple of 3 elements. The first one U, the next one sigma, and the third one V star. And this brings us to the end of this tutorial. In this tutorial we have learned to create matrices using arrays, add, subtract and multiply elements of matrix, find out the inverse of a matrix using the function inv, use the function det to find the determinant of a matrix, calculate the norm of a matrix using the for loop and also using the function norm, finding out the eigenvectors and eigenvalues of a matrix using the function eig and eigvals, then finally calculating the singular value decomposition, that is SVD, of a matrix using the function SVD. Now here are some self-assessment questions for you to solve. First one, A and B are two array objects. Element-wise multiplication in matrix are done by option 1 A star B, then second option multiply A comma B, then dot A comma B, and fourth one element underscore multiply A comma B. Then the second question is EIG A1 and EIG vals A are the same. Is it true or false? Then the final one, the third one is norm A of order, that is ORD, is equal to FRO is the same as norm A. True or false? Now we'll just look at the answers. The first one, element-wise multiplication between two matrices A and B is done using A star B. Second one, the answer is false. EIG A0 and EIG vals A are same. That is, both will give the eigenvalues of matrix A. And the third one, the norm A comma order is equal to FRO and norm A are same, since the order is equal to FRO stands for Frobenius norm. Hence answer is true. So hope you have enjoyed this tutorial and found it useful. Thank you.